Hello, in this lecture we will find the radius of the semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle, angle ABC, this angle is a right angle, it equals to 90 degrees. We also know that side AB of triangle ABC equals to 3 units, and we also know that side or line segment DC equals to 1 unit, and the triangle ABC, actually side AB of triangle ABC is tangent to the semicircle at point B. This point B is the point of contact of tangent AB with the semicircle, and also line segment AE is tangent to the semicircle at point E. Point E is the point of contact of tangent AE with the semicircle, and we want to find out the radius of this semicircle. Okay, so first of all I will present to you rule number 1. According to rule number 1, actually we can call it rule number 1 or two tangents theorem. Rule 1 or two tangents theorem. So according to two tangents theorem states that the lengths of two tangents, the lengths of two tangents from a common external point to a circle are equal. So I will read the two tangents theorem again, or rule number 1. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is actually, if you have this circle and we have external point P, this point is the external point P. Actually point P is an external point in relation to this blue circle, because point P is not located inside this blue circle nor on the blue circle itself, but it is located outside the blue circle. Therefore it is defined as an external point of the circle. So if from the external point P we will draw two tangents to this blue circle, so the first tangent will be actually the touching point between the first tangent and the blue circle will be defined as point A, and we will also draw a second tangent to this blue circle from point B, and we will define the touching point between the second tangent to this blue circle as point B, and actually the length of this first tangent is PA, and the length of the second tangent is PB, and according to two tangents theorem, whenever you draw two tangents from an external point to a circle, then the lengths of those two tangents are equal. That is to say, we drew two tangents from external point P to this blue circle, and according to two tangents theorem, those two lengths are equal to each other. That is to say, PA equals to PB. Okay? So whenever you draw two tangents from an external point of a circle to the circle, then the lengths of those two tangents will be equal to each other. In this case, we drew two tangents from the external point P to this blue circle, and therefore, according to two tangents theorem, the length of those two tangents are equal to each other. That is to say, PA equals to PB. Okay, that is actually two tangent theorem, or rule number one. And we actually can implement rule number one in our drawing. Because here we have the external point A. Point A is an external point in relation to this semicircle because it is not located inside this semicircle, nor on this semicircle, but is outside of this semicircle. Therefore, point A is an external point of this semicircle, and from point A we have two tangents to this semicircle. The first tangent is tangent AB, and actually the length of tangent AB is 3 units, and the second tangent to this semicircle is AE, and according to two tangents theorem, whenever you draw two tangents to a circle from an external point of a circle to a circle, then the lengths of those two tangents will be equal to each other. That is to say, AB will be equal to AE. Okay, according to two tangents theorem, AB equals to AE, or rule number one. But we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units. So from this equality, we can derive that AE also equals to 3 units. AE also equals to 3 units, so AE equals to 3 units. Okay, so in the next step, I will present to you a new rule, rule number 2, and we will implement the new rule in our drawing. So actually, rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you actually have a circle and suppose that the center of this circle is at this point, point O, and we also have a tangent to this circle actually AB is tangent to this blue circle at this point. We define the touching point between the tangent and the blue circle is point M, or point M. It is actually defined as point of tangency and we actually have also a radius from point O to point M. So actually the radius R is drawn to point M, that is a point of tangency. So if this is the situation, then according to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius that is drawn to the point of tangency, in this case it is point M, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so a tangent to a circle, tangent AB, is tangent to the blue circle at point M. Point M is the point of tangency. A tangent to a circle is perpendicular to the radius drawn to its point of tangency. So the radius, this radius, is drawn to the point of tangency, that is to say it is drawn to point M, that is a point of tangency. Therefore the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so that is the meaning of rule number 2, and we'll actually implement rule number 2 in our drawing. In our drawing, we have tangent AE, or AC. AC actually is tangent to the semicircle at point E. Point E is the point of tangency. Is the point of tangency of tangent AC with the semicircle. define the center of this semicircle as point O, and then we will join together points O and E by a straight line. Actually, line segment OE is the radius of this semicircle because of the fact that line segment OE starts from point O, that is the center of this semicircle, and ends at point E, that is a point on the semicircle itself. Therefore, it is the radius of this semicircle, so we will define it as R, radius of the semicircle. So here we have OE is the radius of the semicircle, and this radius is drawn to the point of tangency. That is to say, it is drawn to point E, that is the point of tangency of tangent AC with this semicircle. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. I'll repeat again, because of the fact that the radius OE is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, the tangent AC will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And because of the fact that angle OEC is a right angle, it equals to 90 degrees. Therefore, this triangle OEC is a right triangle. So we'll paint it in the green color. I'll repeat again, the green triangle OEC is a right triangle because of the fact that angle OEC is a right angle. So, in the next step, we will focus on the right big triangle ABC, and we will also focus on the right small green triangle OEC. So, we will focus on the big triangle OEC, and the big right triangle ABC, and the small green triangle OEC. Okay. So I will repeat again. We will focus on the big right triangle ABC, and the small green triangle OEC. Okay, so in those two triangles, we have those two angles are equal to each other. They are both right angles. So we write down that angle ABC of triangle ABC, this angle is equal to angle OEC of the green triangle OEC, and both angles are right angles. They are equal to 90 degrees. So I'll repeat again, angle ABC is equal to angle OEC, and both angles are equal to 90 degrees. And actually this angle is a common angle. It belongs both to the green triangle, and this angle also belongs to triangle ABC. So we write down that angle C equals to angle C. It's a common angle that belongs to both triangles. Okay? I will repeat again. Angle C equals to angle C. It's a common angle that belongs to both triangles. And we have also those two angles are equal to each other. We will prove that those two angles are equal to each other. Or actually angle BAC, this angle BAC is equal to this angle EOC. I'll repeat again. Angle BAC of triangle ABC equals to angle EOC of triangle OEC, and they are equal to each other according to third angle theorem. I'll repeat again. They are equal to each other according to third angle theorem. So, what is third angle theorem? Actually, third angle theorem states that, or we can call it also rule number 3 or third angle theorem. So, according to third angle theorem, if two angles on one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I will read rule number 3 of third angle theorem again. According to third angle theorem, if two angles on one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule or number 3 of the third angle theorem? Actually, according to third angle theorem, if we have triangle ABC, so this is triangle ABC, and we know that this angle is alpha, this angle is beta, and this angle is gamma, and we also have another triangle DEC, triangle DEF. In triangle DEF, this angle is alpha, this angle is beta, and this angle is theta. As you can see from the drawing, on those two triangles we have two angles that are equal to each other. Both those two angles are equal to alpha and beta. So if we have two triangles that have two angles that are equal to each other, like in this drawing, in both those two triangles, we have angles alpha and beta. Then the third pair of angles also equal to each other. Then the third pair of angles, that is actually gamma and theta, will be also equal to each other. That is to say, according to third angle theorem, angle gamma equals to angle theta. So we will actually prove that angle gamma equals to angle theta, because that is what rule number 3 states, that if two triangles have two angles that can congruent to each other, then the third pair of angles also can congruent. That is to say, angle gamma also equals to angle theta. And as you already know, the sum of the angles in any triangle equals to 180 degrees. Okay? And therefore, if we focus on triangle ABC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus gamma must be equal to 180 degrees. Likewise, in triangle DEC, the sum of its angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. Okay? So actually, we have here two equations. Equation number 1 states that the sum of the angles in triangle ABC equals alpha plus beta plus gamma equals to 180 degrees. And equation number 2 states that the sum of the angles in triangle DEF equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. In the next step, we will subtract equation number 1 from equation number 2, and we will get that we get equation number 3 that states that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees, minus 180 degrees is 0, so we got for question number 3 that states that gamma minus theta equals to 0. Here we will add to this equation number 3 theta, and we will get that gamma, angle gamma equals to theta, angle theta. So we actually proved that the third pair of angles also equal to each other. Okay, we proved that the third pair of angles here, angle gamma equals to angle theta. So if we have two triangles that have two angles that are equal to each other, that is to say angle alpha and beta are equal in both triangles, then the third pair of angles also equal to each other, that is to say we proved that angle gamma also equals to angle theta. Okay? We proved that angle gamma also equals to angle theta. Therefore, we proved the third angle theorem. Okay? So, we actually proved that three angles of triangle ABC are equal to three angles of the right green triangle, triangle EOC. Therefore, we actually proved that triangle ABC is similar to triangle EOC. Okay? Triangle ABC is similar to triangle EOC according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle EOC according to angle similarity rule. So, what is angle similarity rule? Angle similarity rule says that if you prove that three angles of one triangle are equal to three angles of another triangle, then you actually proved that those two triangles similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle EOC, we will conclude the following formula. It's true that AB over AC equals to OE over OC. I will repeat again, because of the fact that the right big triangle ABC is similar to the right small green triangle, triangle OEC, we will conclude that AB over AC equals to OE over OC. Okay, but what is the value of AB? The value of AB, according to what is given us in the question, AB equals to 3 units. AB equals to 3 units. So AB is 3. What is the value of AC? As you can see from the drawing, AC, the hypotenuse of triangle ABC, equals to 3 plus, here we will define EC as X. Okay, therefore AC will be equal to AE plus EC, that is to say AC will be equal to 3 plus X. Okay, AC equals to 3 plus X. So we will get that AB is equal to 3 units and AC equals to 3 plus X, and all equals to OE. OE, what is the value of OE? From the drawing we can see that the value of OE is R, the radius of the semicircle, over OC. Actually, OD is the radius of the semicircle because of the fact that line segment OD starts from the center of the semicircle, that is to say from point O, and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle. So in total, we will get that OC equals to OD plus DC. That is to say, OC will be equal to OD, that is R, plus DC, that is 1. In total, OC equals to R plus 1. Okay, so we actually found out that OE equals to R and OC equals to R plus 1. Here we will cross multiply equation number 2, and we will get that 3 times R plus 1 equals to R times 3 plus X. So we cross multiplied equation number 2, and we got that three times R plus 1 equals to R times 3 plus X. Here we will open the brackets in both sides of equation number 2, and we will get that three times R plus 3 equals to 3 times R plus R times X. Here we have 3R on both sides of the equation of number 2, so 3R will get cancelled. And what is left after we cancelled 3R? What is left? It is actually, according to equation number 2, 3 equals to R times X. So here we will divide equation number 2, this equation, by X. So actually it is allowable to divide the equation by X, because X can never be 0, because X, it is actually the side of the green triangle EOC. It equals to EC, so it must be a positive number, it can never be 0. So that is the reason that it is allowable to divide the equation number 2 by X. So we will get that R equals to 3 over X. So we found out that R equals to 3 over X. But we have already found out that according to equation number 1, we found out that actually, in the next step, so we found that r equals to 3 over x. Okay? And in the next step, we will focus on the right triangle, triangle EOC. On the right green triangle, triangle EOC. So on the right green triangle, triangle EOC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will repeat again. In the right triangle, triangle EOC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle, triangle EOC, is OC, so the square of the hypotenuse is OC squared. OC squared equals to the sum of the squares of the perpendiculars equals to OE squared plus EC squared. I'll repeat again. In the right triangle, triangle EOC, the right green triangle, according to the Pythagoras theorem, OC squared equals to OE squared plus EC squared. Okay, but what is the value of OC? The value of OC, it is actually, as you can see from the drawing, OC equals to R plus 1. OC equals to R plus 1 because OD equals to R and DC equals to 1. In total, OC equals to R plus 1. So OC squared will be equal to R plus 1 squared. I will repeat again. OC squared, it is actually R plus 1 squared, and it equals to OE squared. What is the value of OE? From the drawing, you can see that the value of OE is R. So OE squared is R squared plus EC squared. We defined EC as X, therefore EC squared will be equal to X squared. So in total, we got that R plus 1 squared equals to R squared plus X squared. Here we will open the brackets in equation number 1. Actually, R plus 1 squared equals to R squared plus 1 plus 2R, and it equals to R squared plus X squared. So we have R squared in this side of equation number 1, and we have R squared in the other side of equation number 1. So R squared will get cancelled. And what is left after we cancelled R squared? What is left? It is actually 1 plus 2R equals to X squared. This is equation number 1, and according to equation number 2, R equals to 3 over X. Because of the fact that R equals to 3 over X, we will substitute R in equation number 1 by 3 over X. Okay, and we will get that according to equation number 1, 1 plus 2R, and R is 3 over X, equals to X squared. So in total we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we write it down. We get that 1 plus 6 over x equals to x squared. So here we will multiply by x, equation number 1, and we will get that x plus 6 equals to x squared times x is x cubed. Here we will subtract x from equation number 1, and we will get that x cubed minus x equals to 6. We will subtract 6 from equation number 1, and we will get that x cubed minus x minus 6 equals to 0. So here we will add to equation number 1 2x squared, and then we will subtract 2x squared. Minus 2x squared plus 2x squared equals to 0. So we add 0 to equation number 1, that is allowable. Okay, so we will add to equation number 1 2x squared. So it will be x cubed minus 2x squared plus 2x squared is 0. Minus x minus 6 equals to 0. I will repeat again. We actually subtracted from equation number 1 minus 2x squared plus 2x squared is 0. So we added 0 to equation number 1, so we change nothing, so it is allowable. Okay, and we got this expression. Here we know that minus x equals to minus 4x plus 3x. I repeat again, minus x equals to minus 4x plus 3x, so we'll substitute minus x in equation number 1 by minus 4x plus 3x. Okay, and we will get that x cubed minus 2x squared plus 2x squared, and instead of minus x, we will write down minus 4x plus 3x minus 6 equals to 0. Okay, in the next step, we will focus on those two expressions. X cubed minus 2x squared. So we will take a common factor from those two expressions. The common factor will be x squared. And what will be inside the brackets? Inside the brackets, from x cubed, what is left is x. And if we take x squared as a common factor from minus 2x squared, what is left from minus 2x squared is actually minus 2. Okay, and here we will focus on those two expressions, and we will take a common factor of 2x from 2x squared minus 4x. So the common factor is 2x, and inside the bracket we will have what is left from 2x squared after we took 2x as a common factor. What is left, it is actually x. And what is left from minus 4x after we took 2x as a common factor, what is left, it is actually minus 2. and then we will focus on those two expressions, 3x minus 6, and we will take out a common factor of 3 out of these expressions, and what is left from 3x after we took 3 as a common factor, what is left, it is actually x, and what is left from minus 6 after we took 3 as a common factor, what is left, it is actually minus 2, and all equals to 0. So in total we got this expression. So here we can take x minus 2 as a common factor of this expression. So we will get that x minus 2 is a common factor of this expression. So what is left here after we took x minus 2 as a common factor, what is left from this expression is x squared, and what is left from this expression after we took x minus 2 as a common factor, what is left, it is actually plus 2x, and what is left from this expression 3 times x minus 2 after we took x minus 2 as a common factor, what is left, it is actually plus 3. So in total we got, and all equals to 0. So we got this equation number 1, that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we will have two possible solutions to this equation number 1. The first solution will be that x minus 2 equals to 0, and if x minus 2 equals to 0, then 0 times any expression will be equal to 0, and then 0 will be equal to 0. And the second solution that is possible to this equation number 1 is that this expression x2 plus 2x plus 3 equals to 0. X squared plus 2x plus 3 equals to 0, and this, if this expression equals to 0, then 0 times anything will be equal to 0, and 0 equals to 0. So we will focus on the second solution. According to the second solution, x squared plus 2x plus 3 equals to 0, and this is a quadratic equation, and the general formula for a quadratic equation is that ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. Actually x will be equal to minus b plus minus root of b squared minus 4 times a times c over 2 times a. So that is the solution for this general quadratic equation. Okay, and our specific quadratic equation, it is actually x squared plus 2x plus 3 equals to 0. And in our specific quadratic equation, the coefficients of our specific quadratic equation is a equals to 1, b equals to 2, and c equals to 3. Okay, those are the coefficients of our specific quadratic equation. So the only thing that is left to do is to put the coefficients in this formula for x in order to find out the value of x. Okay, and so x will be equal to minus b equals to 2, so minus b is minus 2, plus minus root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a, 4 times a is 4 times 1, times c is 3, over 2a, a is 1, over 2 times 1 is 2. So we found out that x equals to this expression. So actually x equals to the root of 4 minus 4 times 3 is 12. So we found out that x equals to minus 2 plus minus 4 minus 12 is minus 8 over 2. So because of the fact that a negative number doesn't have a root, okay, minus 8 is a negative number and a negative number doesn't have a root, therefore the possibility that, so there is no solution for the quadratic equation x squared plus 2x plus 3 equals to 0. There is no solution to this quadratic equation, so that possibility is incorrect, and we only left with the possibility that x minus 2 equals to 0, x minus 2 equals to 0, okay, x minus 2 equals to 0, if x minus 2 equals to 0, then x equals to 2, x equals to 2, x equals to 2, and we have already found out that r equals to 3, we've already found out that r equals to 3 over x, according to equation number 2, r equals to 3 over x. So we will substitute x by 2 because we found out that x equals to 2. Okay, so according to equation number 1, x equals to 2, so we'll substitute x in equation number 2 by, we will substitute x in equation number 2 by 2, and we will get that r, the radius of the semicircle, equals to 3 over 2 units, or it equals to 1.5 units. So we actually found out that the radius of this semicircle r equals to either 3 over 2 units or to 1.5 units. Okay, so now I'll summarize the lecture. So we actually wanted to find out the radius of this semicircle, and we have here right triangle, triangle ABC. Angle ABC equals to 90 degrees, AB equals to 3 units, and DC equals to 1 unit. And we want to find out the radius of this semicircle. Actually, side AB is tangent to this semicircle at point B, and line segment AE is tangent to this semicircle at point E. And we want to find out the radius of this semicircle. Okay, so I presented to you a new rule, rule number 1. According to rule number 1, that is actually two tangent theorem also, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1 or two tangent theorem? The meaning of two tangent theorem is that if you have this blue circle and you have the external point P, and from the external point P you will draw two tangents to this blue circle, then the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB. So whenever you draw two tangents to a circle from an external point of that circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. And we actually implemented rule number 2, rule number 1 in our circle, because we have here external point A to this semicircle, and from the external point A we have two tangents to this semicircle. The first tangent is AB and the second tangent is AE. So according to rule number 1, whenever you draw two tangents from an external point of a circle to that circle, then the length of those two tangents will be equal to each other. That is to say, AB equals to AE. So I'll repeat again. According to rule number 1, AB equals to AE. According to rule number 1, or according to two tangents theorem, AB equals to AE. But we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units. So from this equality, we will derive that AE also equals to 3 units. So line segment AE equals to 3 units. Okay, then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and we have tangent AB that is tangent to this blue circle at point M. Point M is the point of tangency. Then the tangent AB will be perpendicular to the radius that is drawn to the point of tangency. Actually, this radius, the radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M. Therefore, according to rule number 2, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So, whenever you have a radius that is drawn to the point of tangency, That is to say, in this example, the radius OM is drawn to the point of tangency, that is to say to point M, then the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So this is the explanation of rule number 2, and we actually implemented rule number 2 in our drawing because we have here tangent AC is tangent to the semicircle, it's point E. Point E is the point of tangency, and we have the radius OE. The radius OE is drawn to the point of tangency, that is to say, is drawn to point E. Therefore, the tangent AC will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So, actually, because of the fact that angle OEC, this angle equals to 90 degrees, then the green triangle, triangle OEC, is a right triangle. Okay? Then we focus on the big triangle, big right triangle, triangle ABC, and we also focused on the small green right triangle, triangle OEC. So we focused on those two triangles, triangle ABC and triangle OEC. On those two triangles, we have those two angles that are equal to each other. They are both right angles, so angle ABC equals to angle OEC equals to 90 degrees. And we also have this angle is a common angle. Angle C belongs to both triangle OEC and it belongs also to triangle ABC. So angle C equals to angle C is a common angle. Angle C equals to angle C is a common angle. And we already proved that angle ABC equals to angle OEC equals to 90 degrees. And we also know that those two angles also equal to each other according to third angle theorem. Actually, angle BAC equals to angle EOC according to third angle theorem. So what is third angle theorem? Third angle theorem is actually states, third angle theorem states that if two angles on one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So, what is the meaning of third angle theorem? The meaning of third angle theorem is that if you have those two triangles, triangle ABC, we know that in triangle ABC, this angle equals to alpha, this angle is beta, and this angle is gamma, and we also have triangle DEF. Triangle DEF, this angle equals to alpha, this angle equals to beta, and this angle equals to theta. So in those two triangles, we have two angles that are identical. Angle alpha and beta are equal to each other in both triangles. They have two equal angles. Then the third pair of angles must be also equal to each other. So whenever we have two triangles that has two equal angles, then the third pair of angles must be also equal to each other. That is to say, those third pair of angles are equal to each other. That is to say, angle theta equals to angle gamma according to third angle theorem. And we actually proved that angle theta equals to angle gamma because of the fact that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in triangle ABC equals to 180 degrees. That is to say, alpha plus beta plus gamma equals to 180 degrees. And in triangle DEF, also the sum of the angles equals to 180 degrees. That is to say, alpha plus beta plus theta equals to 180 degrees. So we have here two equations, equation 1 and equation 2. We subtracted equation number 1 from equation number 2. So here alpha minus alpha is 0, beta minus beta is 0, and we have gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we got that gamma minus theta equals to 0. Here we added theta to equation number 3, and we found out that angle gamma equals to angle theta. So we actually proved that angle gamma equals to angle theta. That is to say, if we have two triangles that have two angles that are equal to each other, then the third pair of angles must be also equal to each other. That is to say, angle gamma equals to angle theta. We proved that angle gamma equals to angle theta, so we proved that the third angle theorem is true. So we actually proved in our original drawing that triangle ABC has three angles that congruent to three angles of the green triangle, triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Actually, if you prove that three angles of one triangle congruent to three angles of another triangle, then you prove that those two triangles actually similar to each other according to angle similarity rule. From the fact that triangle ABC is similar to triangle OEC, we concluded that AB over AC equals to OE over OC. Okay, AB over AC in triangle ABC equals to OE over AC in triangle OEC. Okay, and we know that AB equals to 3 units, AC equals to 3 plus X, AC equals to 3 plus X. Okay, AB equals to 3 units. It is given as the equation AC equals to 3 plus X, OE equals to R, and OC, as you can see from the drawing, OC equals to R plus 1. OC equals to R plus 1. Okay, so OE equals to R and OC equals to R plus 1. In total, we got that 3 over 3 plus X equals to R over R plus 1. Here, we cross multiply the equation number 2, and we got that three times R plus 1 equals to R times 3 plus X. Here we open the brackets in both sides of the equation, and we got that 3R plus 3 equals to 3R plus RX. Here we subtracted 3R from equation number 2, and we got that 3 equals to R times X. Then we divided equation number 2 by X, and we got that R equals to 3 over X. So according to equation number 2, R equals to 3 over X. Okay, then we focused on the right triangle, triangle EOC. Triangle EOC is the right triangle because this angle equals to 90 degrees, according to rule number 2. On the right triangle, triangle EOC, according to the Pythagorean theorem, OC square plus OE square equals to EC square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OE square plus EC square. Okay, OC square equals to OE square plus EC square. And actually, OC equals to R plus 1. And so OC square is R plus 1 square. OE equals to R, therefore OE square equals to R square, and EC equals to X, according to our definition. Therefore, EC squared equals to x squared. So in total, we got that r plus 1 squared equals to r squared plus x squared. Here we open the bracket in equation number 1 in this side of the equation, and we got that r plus 1 squared equals to r squared plus 1 plus 2r, and it equals to r squared plus x squared. We subtracted r squared from equation number 1, and we got that 1 plus 2r equals to x squared, according to equation number 1. 1 plus 2r equals to x squared, and according to equation number 2, we've already found out that r equals to 3 over x. So we can substitute r in equation number 1 by 3 over x, because r equals to 3 over x, according to equation number 2. So we substituted r by 3 over x in equation number 1, and we found out that that 1 plus 2 times r, and r is 3 over x, equals to x squared. So here 2 times 3 is 6, so we got that 1 plus 6 over x equals to x squared. Then we multiplied the equation number 1 by x, and we got that x plus 6 equals to x cubed. Then we subtracted 6 from equation number 1. We subtracted x from equation number 1, and we got that x cubed minus x equals to 6. Then we subtracted 6 from equation number 1, and we got that x cubed minus x minus 6 equals to 0. Then we actually subtracted 2x squared, and then we added 2x squared to this equation number 1. I'll repeat again. We subtracted 2x squared, and then we added 2x squared to equation number 1. Actually, minus 2x squared plus 2x squared is 0, so we actually changed nothing. Therefore, this operation is allowable, and we got this expression. Then we substituted x in this equation number 1 by minus 4x plus 3x, because minus 4x plus 3x equals to minus x. So we subtracted minus x by minus 4x plus 3x, and we got this expression. Then we took a common factor from these two expressions, x cubed minus 2x squared. We took a common factor of x squared, and inside the brackets we have x minus 2. Then we took a common factor of 2x out of those two expressions, and inside the brackets we have x minus 2, and we also took a common factor out of those two expressions, and inside the brackets what is left is x minus 2. So we got this expression. From this expression we took a common factor of x minus 2, and inside the brackets we have, from this what is left is x squared. From this expression what is left is 2x, and from this expression what is left after we took x minus 2 as a common factor, what is left is it is actually 3. So here we have this equation number 1, and we have two solutions that are possible for this equation number 1. The first solution that is that x minus 2 equals to 0, and the second solution is that x squared plus 2x plus 3 equals to 0. Okay, we have those two solutions, either x minus 2 equals to 0, or x squared plus 2x plus 3 equals to 0. So we focused on the second solution. In the second solution we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. And in this general quadratic equation, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to this special formula. So in our specific quadratic equation, x squared plus 2x plus 3, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. Then we put the data inside this equation in order to find out the value of x. And we actually found out that x equals to minus b, b is 2, so minus b is minus 2, plus minus root of b squared, b is 2, so b squared is 4, b squared is 2 squared, 2 squared is 4, minus 4 times a times c. 4 times a is 1, 4 times 1 is 4, and c is 3. 4 times 3 is 12. So in total we got that x equals to minus 2 plus minus root of minus 4 minus 12 is minus 8. So we actually found out that x equals to minus 2 plus minus root of minus 8. And because of the fact that a negative number doesn't have a root, minus 8 is a negative number, and there is no root for a negative number. Therefore, this possibility is incorrect because there is no solution for x. Therefore, we left only with the possibility that x minus 2 equals to 0, because the second possibility that x squared plus 2x plus 3 equals to 0 is not correct because there is no solution for x. There is no solution for x, and the only possibility that is left is the x minus 2 equals to 0. If x minus 2 equals to 0, then x equals to 2. And according to equation number 1, r equals to 3 over x. So we'll substitute x by 2 because x equals to 2. So we'll substitute x by 2, and we'll get in equation number 2 that r equals to 3 over 2 units. So we actually found out that the radius of the semicircle, the radius of this semicircle, r equals to either 3 over 2 units or it equals to 1.5 units. I'll repeat again. The radius of this semicircle, r equals to either 3 over 2 units or it equals to 1.5 units. Okay, thank you very much.